Hi everyone. I'm going to discuss solving real world problems involving linear inequalities. Previously, you learn how to graph systems of linear inequalities, wherein we were able to identify the shaded intersection of the given linear inequalities. So those shaded intersections again proves that there is a solution set that would satisfy all the given linear inequalities. Now, the graph only shows the first quadrant of the coordinate or of the coordinate plane, since the weight values in the real world are always non-negative. So points outside the first quadrant will not represent real world solutions to any linear inequality problems. Now, before we begin working on real world problems involving linear inequalities, you have to take note of these keywords that would translate mathematical statements into real inequalities. So we have for less than, greater than, less than, or equal to, greater than, or equal to. Now, if like we're going to consider some of these expressions, like we focus on less than or equal to, then for example, let's make use of at most. So like in school, for you not to be drop out of the class, you should not incur, or you should incur at most 10 absences. So when we say at most 10 absences, so the maximum allowable absences that you are allowed for you not to be dropped out of school is 10. So it has to be, the absences must be represented by the less than or equal to inequality. On the other hand, when we make use of, let's say, at least, in a statement like for you to maintain your scholarship, you need to get a general average grade of at least 85. So, meaning your grade should not be less than, or it should be from 85 or above. So, that's what we meant by greater than or equal to inequality. So, understanding each keyword and translating this into linear inequalities is necessary for us to come up with a correct solution for the given linear inequality problems. So let's start working with the first problem here. So the first problem, so Miguel can spend at most, so Miguel can spend at most 30 pesos for his lunch during recess. So we have the keyword here, at most. It costs him 10 pesos per snack and 5 pesos per drink. Find all the possible amounts of the two items that can be bought. Okay? So when we say at most, again, this is associated with less than or equal to inequality symbol. And we have these two data, cost of snack and drinks. Okay. Now, if we will let um, X be the number of snacks, taken by Miguel and why be the purchases of drinks he made. So we can come up with this inequality 10x plus 5y is less than or equal to 30. So in the previous discussion, you learn about sketching the graph of inequality. So the first thing that we can do is temporarily we can replace the symbol, inequality symbol to equality symbol. So we'll come up with 10x plus 5y equals 30. Now, 2 points determine a line, so we will be needing 2 points. From this equation, it would be better if we consider the x and the y intercepts, and that is possible by assigning x equals 0, and then we can come up with the possible value of y and vice versa. So if we let x equal 0, then your y is equal to, so we'll isolate y on one side, and then we have 5y equals 30, and then we divide both sides by 5, so we obtain y equals 6. So we have 1 point already, 0.6. And then if we will let y this time equals 0, so what would be the value of x? So we will replace y to 0, so we have 10x plus 5 times 0, we have 30. So 10x equals 30. So we divide both sides by 10 to obtain the value of x. So we have x equals 3. So we already have 2 points, namely 0, 6 and 30. Now, by plotting the points, 0, 6, and then the other one is 30, and then connecting the points with a solid line since the inequality involves less than or equal to. So we have this. And then going back to the original inequality, this is 10x plus 5y is less than 30. So since the inequality is less than, then the solution set must be below the solid line. Now, take note that the solution or the points on the solid line are also considered as the solution. So if we're going to consider a few points of the solution, a few points here represented by the shaded region, which are actually considered as the possible um, amounts of the two items that Miguel can buy to spend wisely his allowance. So if we have to consider 1 here, so we have if x equals 1, so let me use another color here. If we're going to consider 1 here, and then a point on the line, if we have like, for example, 2, 2. Okay. So if we have 1 here, so meaning Miguel will buy a snack and a drink. Okay. So that would mean that we have 10 times 1 plus 5 times 1 is less than or equal to 30. So this is 15, which is less than or equal to 30. This makes the statement true. So the solution set for a given inequality, when substituted to the given inequality, must come up with a true statement. Okay. Another solution satisfying this inequality is the point on the solid line. So meaning these are the boundaries. So we have 2, 2 here. So we have 10 times 2 plus 5 times 2 is less than or equal to 30. So 30 is less than or equal to 30. Wherein 30 really equals 30. So true. So if on the other hand, Miguel would purchase two sandwiches and two drinks, so he will be able to consume 30 pesos for that, and that does not exceed with Miguel's allowance or lunch allowance. So that would mean that 2 is considered as a solution also, a possible solution. Now, what if we go beyond the shaded region? Like we consider this point, and this is 5. No, no, this is 1 5. Okay, so if you consider 1 5, like substituting 1 5 to the inequality, we have 10 times 1 plus 5 times 5 is less than or equal to 30. So this is 10 plus 25 is less than or equal to 30. 35 is less than or equal to 30. Now, this is a false statement. That's why 1 5 is not a possible solution for this inequality problem. Okay? So let's proceed with the next example. Now, Alex, a working student, has two part-time jobs, one paying 42 per hour and another is paying 28 per hour. So he must earn at least 364 per week to pay expenses, all his expenses while attending college night classes. So write an inequality that shows that various ways he can schedule his time to achieve his goal. So this is like solving for the solution of the inequality described by the situation. And let's go back with the problem again. And the key words here, so we have at least. So again, at least is associated with greater than or equal to. Okay. And then 364. And Alex is working on Alex has two part-time jobs in short. So one is paying 42 per hour. So if we will let that be the x variable, so x that pays 42 per hour. Okay, 42 pesos per hour. The other part-time job can be represented by y that pays 28 pesos per hour. Now, the two part-time jobs actually supports Alex college classes or college night classes. Okay? So the question here is we're going to write an inequality that shows the various way he can schedule his time to achieve his goal. Okay? So meaning how many hours must Alex work that pays 42 pesos per hour? And then how many hours will Alex work in another part-time job that pays 28 per hour? So we can make use of the inequality 42x plus 28y. So we have 42x plus 28. Wait, this is 28y is greater than or equal to 364. Okay, so we can like convert this inequality to the slope intercept form. So we're going to like isolate y. So we have 28y is greater than or equal to negative 42x plus 364. And then we will divide both sides by 28, 28 here. So we will obtain y is greater than or equal to. So we're going to consider the lowest term for the common factor for 42 and 28 for us to come up with its lowest term. So I guess we have 42, 21 over. So we have 21. This is negative 21 all over 14 plus 364 divided by 28 is 13. Now, from this simplified inequality, we know that this 13 will serve as the y-intercept. And if that's the y-intercept, then we already have 1 point at 0, 13. Now, to obtain the other point, we need to consider the coefficient of x, which is the slope. So m here is negative 21 over 14. Okay, so what we're going to do here is to come up with another point that would consider that would be considered to determine 2 points or to come up with 2 points. Another way of locating another point is like considering the inequality as linear equation, like if we consider some positive values of x, like as what I mentioned in the previous slide, working on real world problems allows us only to work with some values of x and y which are greater than 0. So for example, if we're going to select like x equals 2 and we temporarily replace an equality symbol, 28y equals 364. And if we will let x equals 2, let's work on the values of y. So this is 2 plus 28y equals 364. So this is 28y equals 364 less 84. And this is 28y equals 280. So 280 is the difference between 364 and 84. So we got y equals 10. So if x is 2, y is 10. So we already have another point na 210. So we can plot this point and connect this along with 013. So we are able to connect the points and extend on both sides. So we come up with a solid line since the inequality is greater than or equal to. Now, since as what I was saying, this is greater than or equal to, the solution set must be above the solid line. So, so this must be the possible solution. Of course, we have to note also that Alex can work like a total of 24 hours in a day. So it should not exceed 24 hours. If we're going to select a possible solution within the shaded region, which is considered as the solution set, like if we're going to select a point here on the line, and then another is this. Okay, so this is 410. So imagine he will be working for 14 hours if we select 410 here. So so we have 42 times 4 plus 28 times 10. And this is, or this must be greater than or equal to 364. So 42 times 4 equals 168, while 28 times 10 is 280. Is this greater than or equal to 364? And this exceeds 364. So this is considered as a possible or solution. And then if we're going to consider another possible number of hours that Alex would work in order to support his night class would be 210. So if Alex will work for a job that pays 42 hours for 2 hours and 10 hours on a job that pays 28 pesos, so he will have 42 times 2 plus 28 times 10 is greater than or equal to 364. So this is 84 plus 280 is greater than or equal to 364. So we have 364 is greater than or equal to 364. Now, if we're going to consider like a solution or a point which is beyond the solution set, like if we're going to consider 80 here, okay? So if we substitute 80, so this is 42 times 8 plus 28 times 0 is greater than or equal to 364. So this is 42 times 8 equals 336. And 336 class is it greater than or equal to 364? So this leads to a false statement since 810 is not a possible solution for this inequality. Okay, next. So a clinic is writing a budget plan for the yearly inventory so they can buy additional supplies. So they estimate that the cost of a set of face masks is 80 pesos per box and 120 for half gallon bottle of alcohol. And they plan that they couldn't spend more than 2,400. So write the inequality that best describes the problem. So take note of the phrase they couldn't spend more. Okay? So it has to be the negation of more, which would be equivalent to less. Okay? And could not spend more than. So it has something to do with less than inequality symbol, followed by the amount 2,400 pesos. Okay? So if we will let X be the um number of face masks per box or number of yes, face mask purchase per box, and then Y be the number of or the amount of or the purchase of alcohol per half gallon. So this is per half gallon. Okay. So we'll come up with an inequality 80x plus 120 y is less than 2,400. So if we're going to convert this into slope intercept form, so we have 120y is less than negative 80x plus 2,400, and we divide both sides by 120. So we have y is less than negative. So we have 2 all over, like this is 3x plus 2. Okay. So or rather 2,400 when divided by 120 is 20. So by inspection, 20 is considered as the y-intercept. So by plotting 0, 20 here, we obtain 1 point, and considering the slope m equals negative 2/3, so we will be able to locate another point starting with 0, 20. Now, again, we limit the solution to x and y greater than 0. So the slope must be within the first quadrant. Okay, so the points that we're going to consider should fall on the first quadrant. So maybe we will be moving out by 2 down, and then run by 3 to the right. So this is 1, 2, 1, 2, 3. Okay. So you can select um, another point by considering this point and working on the slope. So you can go down by 2 units and then run by 3. 1, 2, 3. Same, so it's the same thing if you want to add another point. So move down by 2, then run by 3. 1, 2, 3. And then connecting the points will come up with this dash line since we are using less than inequality symbol. Now, again, since this is less than inequality symbol, so the solution set should be below the dash line. And again, the shaded region must be within the first quadrant only since we want to come up with the x and the y values greater than 0. Okay. So if we're going to select a few points from the shaded area, like if we're going to consider 018, and then another is 12:8, or rather 12:7. So this is 12:7, and obviously this is 018. Then we select a point um beyond the shaded region, like if we're going to consider 30 and 1, and substituting this to the inequality, and let's begin with 018. So substituting this to the inequality, so we have 80 times 0 plus 120 times 18. So we have less than 2,400. So 120 times 18 is 2160, which is less than 2,400. So this is a true statement because this is considered as the solution, okay, possible solution. And then let's consider, or rather, this is um, 712 instead. So if we're going to consider 712, this is 80 times 7 plus 120 times 12, less than 2,400. So we know that 80 when multiplied by 7 equals 560. And this is 120 times 12. We have 1,440. And this is definitely less than 2,400. And exactly that is amounting only to 2,000. Again, this is a true statement because this is a possible solution. And the point which is beyond this shaded region, 31, so we have 80 times 30 plus 120 times 1. Is it less than 2,400? So we know that 80 times 30 is 2,400 already. And then plus 120, definitely this exceeds 2,400. And to be exact, this is 2,520, less than 24. So this is now a false statement. Okay, so that's why 31 is not within the shaded region. So technically, this is how we work on the solution for the inequality First is we should know how to translate English expressions to mathematical expression, and then come up with an inequality, solve for the inequality, and then we will be able to identify the solution set for that given real world problem involving inequality. So that's it for now.